students, I am Rashmi and you are watching my channel Tricks to Crack Competitive Exams. In this video, I am going to explain number system of class 9th. Solutions to each and every question of all the exercises has been solved. Start with exercise 1.1. Question number 1. Is 0 a rational number? Can you write it in the form P by Q, where P and Q are integers and Q is not equal to 0? Answer: yes, 0 is a rational number. 0 is also a whole number, but it is not a natural number. And it is represented as in the form of P by Q, that is 0 by 1 or 0 by 2 or 0 by 3, etc. Second question. Find 6 rational numbers between 3 and 4. Answer: there are infinite rational numbers in between 3 and 4. This 3 and 4 can be represented as three into 8 by 8, that is 24 by 8, and 4 can be represented as 4 into 8 by 8, that is 32 by 8 respectively. Therefore, rational numbers between 3 and 4 are 25 by 8, 26 by 8, 27 by 8, 28 by 8, 29 by 8, 30 by 8. So these are the rational numbers between 3 and 4. Now third question. Find 5 rational numbers between 3 by 5 and 4 by 5. Answer: there are infinite number of rational numbers between 3 by 5 and 4 by 5. So this 3 by 5 and 4 by 5 can be represented as 3 by 5 is equal to 3 into 6 by 5 into 6, and 4 by 5 can be represented as 4 into 6 by 5 into 6. So 3 by 5 is 18 by 30, 4 by 5 is 24 by 30. In between 3 by 5 and 4 by 5, the rational numbers are 19 by 30, 20 by 30, 21 by 30, 22 by 30, and 23 by 30. So these are the rational numbers between 3 by 5 and 4 by 5. Fourth question. State whether the following statements are true or false. Give reasons for your answer. First one, every natural number is a whole number. Second one, every integer is a whole number. Third one, every rational number is a whole number. Answer: first one, every natural number is a whole number, it is true. Since the collection of whole numbers contain all natural numbers, second one, every integer is a whole number, it is false, because as integer is negative, but whole numbers are positive. For example, -5 is an integer, but it is not a whole number. Now third one, every rational number is a whole number. It is false, because every rational number may not be a whole number. They may be fractional. So for example, 1/2 is a rational number, but 1/2 is not a whole number. Exercise 1.2, question number 1, state whether the following statements are true or false. Justify your answer. First one, every irrational number is a real number. Second one, every point on the number line is of the form m, where m is a natural number. And third one, every real number is a irrational number. Now first one, it is true since the real numbers are made up of rational and irrational numbers. Second one, every point on the number line is of the form square root of m. So here it should be square root of m, where m is a natural number. Answer is false, as negative numbers are not expressed as the square root of any other number. Third one, every real number is an irrational number. It is also false, as real numbers include both rational and irrational numbers. Therefore, every real number cannot be an irrational number. Second question, Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Answer: if numbers such as square root of 4 is equal to 2, square root of 9 is equal to 3 are considered, then here 2 and 3 are rational numbers. Thus, the square roots of all positive integers are not irrational. Third question. Show that square root of 5 can be represented on the number line. Answer: we know that square root of 4 is equal to 2. Then square root of 5 is equal to square root of 2 square plus 1 square can be represented on the number line. Now draw a line like this. Mark the points as 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. Here square root of 5 can be written as square root of 2 square plus 1 square, means one is 2 unit and other is 1 unit. So this is 2 and this is 1 unit. Mark it as A, B. And this hypotenuse will be of square root of 5, or you can take a protractor and draw a line like this. So this point C is a root 5, or mark a point A representing 2 on the number line. Now construct AB of unit length perpendicular to OA. Then taking O as center and OB as radius, draw an arc C is representing square root of 5. Fourth question. It is based on classroom activity constructing the square root spiral. So answer is, take a large sheet of paper and construct the square root spiral in the following pattern. Start with a point O and draw a line segment OP1 of unit length. Draw a line segment P1, P2 perpendicular to OP1 of unit length, and see this figure. Join OP2. Try to draw these figures. First square root of 2 with the unit lengths, afterwards square root of 3, then square root of 4, as well as you can draw square root of 5, square root of 6, like this only. Now draw a line segment P2 P3 perpendicular to OP2 of unit length and join OP3. Then draw a line segment P3 P4 perpendicular to OP3 of unit length and join OP4. Continuing in this manner, you can get the line segment P of n minus 1 into Pn by drawing a line segment of unit length perpendicular to OPn minus 1. Thus, you have created the points P2, P3 and so on up to Pn and join them to create a beautiful spiral depicting square root of 2, square root of 3 and square root of 4. Exercise 1.3, first question. Write the following in decimal form and say what kind of decimal expansion each has. I will solve it one by one. Solution. First one, 36 by 100. So which is equal to 0.36, means it is a terminating decimal expansion. Second one, 1 by 11. For 1 by 11, we will do division, point, then 0, again take 0, it becomes 100, 11 9s are 99, remainder is 1, again it gets repeated. So answer is 0.09 bar. Here decimal expansion is non-terminating repeating. Now third one, 4 integer 1 by 8. So it can be written as 33 by 8. It will be equal to 4.125. It's a terminating decimal expansion. Fourth one, 3 by 13. 3 by 13, then here do the rough work, 13 with 3, take point, then it becomes 30, 13 2s are 26, remainder is 4, now it is 40, 13 3s are 39, remainder is 1, next 13 7s are 91, remainder is 9, next 13 6s are 78, remainder is 12, 13 9s are 117, now remainder is again 3. So it will be repeated once again. Answer is 0.230769 whole bar. It is a non-terminating and repeating, or you can write recurring also, repeating decimal expansion. Now fifth one, 2 by 11. Divide it separately. 2 with 11. Take point, then it will be 0. 11 ones are 11. Remainder is 9. Again it will divide with 8. 11 8s are 88. Remainder is 2. 1 8 is repeated. Then answer is 0.18 bar. It's a non-terminating repeating decimal expansion. Now sixth one, 329 divided by 400. So which is equal to 8, 2, 2, 5. So 0.8225, it's a Terminating decimal expansion. Second question. You know that 1 by 7 is equal to 0.142857 bar. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 are without actually doing the long division? If so, how? Solution. Yes, without doing the long division, we can predict the decimal expansion. So, it can be done as follows. Two by 7 is equal to 2 into 1 by 7, which is equal to 2 into 1 by 7 value given as 0.142857 whole bar. Now multiply these two numbers, it will be 0.285714 whole bar. And 3 by 7 is equal to 3 into 1 by 7, which is equal to 3 into 1 by 7 is 0.142857. Multiply. Then it will be equal to 1, 7, 5, 8, 2, 4. That is 0.428571. Likewise, 4 by 7 is equal to 4 into 1 by 7, which is equal to 4 into 1 by 7 is 0.142857. Now multiply these two numbers. We will be getting 8, 2, 4, 1, 7, 5. That is 0.571428 whole bar. Again 5 by 7, which is equal to 5 into 1 by 7, which is equal to 5 into 0.142857. Multiply these two numbers, then we will be getting 5, 8, 2, 4, 1, 7. That is 0.714285 whole bar. And 6 by 7 is equal to 6 into 1 by 7, which is equal to 6 into 1 by 7 is 0.142857 whole bar. Multiply these two numbers, then we will be getting 2, 4, 1, 7, 5, 8. That is 0.857142. Question number 3. Express the following in the form P by Q, where P and Q are integers and Q is not equal to 0. We will solve one by one. Solution for the first one. It is given that 0.6 bar, that is equal to 0.6666. Let x is equal to 0.666, then 10x will be 6.66, or we can write it as a 10x is equal to 6 plus 0.66. Then 10x is equal to 6 plus x. Simplified, we will be getting 9x is equal to 6, then x is equal to 6 by 9 or 2 by 3. Now second one, 0.47 bar. So which is equal to 0.47777. Let x is equal to 0.477. Then 10x is equal to 4.777. Or we can write it as 10x is equal to 4 plus 0.3 plus 0.477. This implies 10x is equal to 4 plus 0.3 plus x. Or simplified, we will be getting 9x is equal to 4.3. Then x is equal to 4.3 by 9 or 43 by 90. Now third one, 0.001 whole bar. So this is equal to 0.001, 001, 001 and so on. Let x is equal to 0.001, 001 so on. Then 1000x is equal to 1.001, 001. Or we can write it as 1000x is equal to 1 plus 0.001, 001. Or 1000x is equal to 1 plus x. Simplified, we will be getting 999. X is equal to 1. Then x is equal to 1 divided by 999. Question number 4. Express 0.999 and so on in the form P by Q. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. Solution. Let x is equal to 0.999 so on. Then 10x is equal to 9.99 or 10x can be written as 9 plus 0.999. So 10x will be 9 plus x. This implies 9x is equal to 9. Then x value is equal to 9 by 9, that is 1. So we got x value as 1. Yes, we are surprised to get an integer 1 because after decimal 9 is repeated infinitely and this will tend to an integer. Question number 5. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Solution. Now divide 1 by 17. Take 0, then again 0, it will be 100. 17 5s are 85. Remainder is 15. Then 17 8s are 136. Remainder is 14. Again 17 8 is 136. Remainder is 4. 17 2 is 34. Remainder is 6. 17 3 is 51. Remainder is 9. 17 5 is 85. Remainder is 5. Then 17 2 is 34. Remainder is 16. 17 9 is 153. Remainder is 7. Again 17 4 is 68. Remainder is 2. 17 1 is 17. We got remainder as 3. Again 17 1 is 17. Here remainder is 13. Now it will divide with 7. 17 7 is 119. Remainder is 11. Again it will divide with 6 is 17 6 is 102. Remainder is 8. 17 4 is 68. Remainder is 12. It will again divide with 7. 17 7 is 119. We got a remainder as 1, which is similar to the dividend. Then these numbers are repeated once again. So we got 1 by 17 is equal to 0.058823294117647. So these numbers are repeated. A block of 16 digits is repeated. Sixth question. Look at several examples of rational numbers in the form p by q, where q is not equal to 0. P and q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property q must satisfy? Solution. Terminating decimal expansion will occur when denominator q of rational number p by q is either of 2, 4, 5, 8, 10 and so on. We can take some examples. 9 by 4 is equal to 2.25. 11 by 8 is equal to 1.375. 27 by 5 is equal to 5.4. 36 by 25 is equal to 1.44. Then 7 by 125 is equal to 0.056. 29 by 16 is equal to 1.8125. Here it can be observed that terminating decimal may be obtained in the situation where prime factorization of the denominator of the given fractions has the power of 2 only or 5 only or both. Seventh question. Write 3 numbers whose decimal expansions are non-terminating and non-recurring. Solution. 3 numbers whose decimal expansions are non-terminating, non-recurring are 0.01, 001, 0001, 00001 and so on. Next 0.72, 0, 72, 00, 72, 000 and so on. 0.02, 002, 0002, 4 zeros, 2 and so on. Eighth question. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Solution. 5 by 7. So it can be written as, do the division here. 5 will not divide with 7, then take point, here it will be 0. 7 sevens are 49, remainder is 1, then 7 ones are 7, remainder is 3, again 7 fours are 28, 7 twos are 14, 7 eights are 56, 7 fives are, it is 35. Again we got a remainder which is same as dividend. So the numbers will be repeated. 5 by 7 is equal to 0.714285 and 9 by 11 is equal to, divide it, 11 8s are 88, again 11 1s are 11. We got remainder which is same as divisor, then it will be repeated. Answer is 0.81 whole bar. Therefore, the required rational numbers are, in between these two numbers you can write 0.73, 07300, 73000 and so on, and 0.75, 07500, 75000 and so on. Third number is 0.790, 7900, 79000 and so on. Ninth question. Classify the following numbers as rational or irrational. I will be solving one by one. Solution for the first one. Square root of 23. So which is equal to 4.79583152 and so on. So it has non-terminating, non-recurring decimal expansion. Square root of 23 is non-terminating and non recurring decimal expansion. Second one, square root of 225, that is 15. So 15 is, it is a terminating rational number. First one, root 23 is a irrational number. Second one is a rational number. Now third one, 0.3796. It's a terminating decimal expansion. So it's a rational number. Fourth one, 7.478478, or it can be written as 7.478 whole bar. It's a non-terminating recurring. If it is non-terminating recurring, then it is a rational number. Fifth one, 0.10, 100, 100, 140, 1 and so on. Then it is a non-terminating, non-recurring decimal expansion. If it is a non-terminating and non-recurring, then it is a irrational number. Exercise 1.4. First question. Visualize 3.765 on a number line using successive magnification. Solution. So draw a number line representing 3.765. So this 3.7 lies between 3 and 4. So draw a number line as shown. In between there is a 3.5. Make divisions like this. 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9. So 3.765, it lies in between 3.7 and 3.8. Again draw a line from 3.7 to 3.8. And make a smaller divisions. Now 3.765 lies in between 3.76 and 3.77. Now again draw endpoints with 3.76 and 3.77. Mark in between lines as shown. So now 3.765, it is present in between of the third number line. Now represent it with a box. Second question, visualize 4.26 bar on the number line up to 4 decimal places. Solution. So this 4.26 bar can be written as 4.2626 They have asked up to 4 decimal places. That's why we have written 4.2626. Then draw a number lines. First, 4.2 is present in between 4 and 5. So in the first number line, endpoints are 4 and 5. Other lines mark it as 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, 5.0. So this is 4.26 which lies in between 4.2 and 4.3. So next number line you draw with the endpoints 4.2 and 4.3 and mark in between lines. Again 4.262 lies in between 4.26 and 4.27. So mark these 2 points. Draw another number line with the endpoints 4.26 and 4.27. In between also you have to mark the points as 4.261 to 4.270. Now this 4.2626 lies in between 4.262 and 4.263. Again draw a number line with the endpoints 4.262 and 4.263. Mark in between lines also. After marking these points, now we have to mark 4.2626, which is the required answer. Next, exercise 1.5. First question. Classify the following numbers as rational or irrational. Solution to the first one, 2 minus root 5. Here 2 is a rational number and root 5 is a irrational number. Subtraction of rational number and irrational number is always an irrational number. Or we can make subtraction also. 2 minus this root 5 is 2.2360679, which is equal to minus 0.2360679, which is a irrational number. Now second one, 3 plus root 23 minus root 23 equal to 3 plus root 23 minus root 23. These two get cancelled. Remaining is 3. 3 can be written as 3 by 1. It is a rational number. Third one, 2 root 7 by 7 root 7, which is equal to this root 7 get cancelled, equal to 2 by 7. 2 by 7, it is a rational number. Now fourth one, 1 by root 2, or it can be written as root 2 by 2, which is equal to 0.7071067811 and so on. It is a non-terminating and non-recurring. Then it is a irrational number. Fifth one, 2 pi. Here 2 is a rational number and pi is a irrational number, and product of non-zero rational number and irrational number is always an irrational number. Question number 2. Simplify each of the following expressions. Now, solution to the first one, 3 plus root 3 into 2 plus root 2, which is equal to 3 into 2 plus root 2 plus root 3 into 2 plus root 2. Again simplified, it will be 6 plus 3 root 2 plus 2 root 3 plus root 3 into root 2, which is equal to 6 plus 3 root 2 plus 2 root 3 plus root 6. Second one, 3 plus root 3 into 3 minus root 3. Here we will be using the identity a plus b into a minus b is equal to a square minus b square. So which is equal to 3 square minus root 3 whole square. 3 square is 9 minus 3. 9 minus 3 is 6. Now third one, root 5 plus root 2 whole square. Here a plus b whole square is equal to a square plus b square plus 2ab. Now it will be root 5 whole square plus root 2 whole square plus 2 into root 5 into root 2, which is equal to 5 plus 2 plus 2 root 10 or 7 plus 2 root 10. Fourth one, here we will be using the identity a minus b into a plus b, that is equal to a square minus b square. Now root 5 square minus root 2 whole square, which is equal to 5 minus 2, that is 3. Question number 3. Recall pi is defined as the ratio of the circumference of a circle to its diameter. That is pi is equal to c by d. This seems to contradict the fact that pi is irrational. How will you resolve this contradiction? Answer: there is no contradiction. When we measure a length with the scale or any other instrument, we only obtain an approximate rational value we never obtain an exact value. For this reason, we may not realize that either C or D is irrational. Therefore, the fraction C by D is irrational. Hence, pi is irrational. If C by D is irrational, then pi is irrational. Question number 4. Represent square root of 9.3 on the number line. Solution. Firstly, draw AB is equal to 9.3 units. Now, from B, mark a distance of 1 unit. Let this point be C. Let O be the midpoint of AC. Now, draw a semicircle with center O and radius OA. Draw square root of 9.3 as shown in the figure. Let us draw a line perpendicular to AC passing through point B and intersecting the semicircle at point D. So, draw like this. This is point D. Therefore, distance BD is equal to square root of 9.3. Draw an arc with center B and radius BD which intersects the number line at point E. So, point E represents square root of 9.3. Question number 5. Rationalize the denominators of the following. First one, 1 by square root of 7, which is equal to 1 by square root of 7 into square root of 7 by square root of 7, which is equal to square root of 7 by 7. Second one, 1 by square root of 7 minus square root of 6. For this one, on multiplying both numerator and denominator by square root of 7 plus square root of 6, then we get 1 by square root of 7 minus square root of 6 into square root of 7 plus square root of 6 divided by square root of 7 plus square root of 6. It is equal to square root of 7 plus square root of 6 divided by square root of 7 whole square minus square root of 6 whole square. Now this is equal to square root of 7 plus square root of 6 divided by 7 minus 6, or this is equal to square root of 7 plus square root of 6, which is the required answer. Now third one, 1 divided by square root of 5 plus square root of 2. Here on multiplying numerator and denominator by square root of 5 minus square root of 2. Now this is equal to 1 divided by square root of 5 plus square root of 2 into square root of 5 minus square root of 2 divided by square root of 5 minus square root of 2. Now multiply it, we will be getting square root of 5 minus square root of 2 divided by square root of 5 whole square minus square root of 2 whole square. Now this will be square root of 5 minus square root of 2 divided by 5 minus 2, or it can be written as square root of 5 minus square root of 2 divided by 3, which is the required answer. Now fourth one, here on multiplying numerator and denominator by square root of 7 plus 2, then we get 1 divided by square root of 7 minus 2 into square root of 7 plus 2 divided by square root of 7 plus 2. Now multiply, we will be getting square root of 7 plus 2 divided by a plus b into a minus b whole square formula, that is square root of 7 whole square minus 2 square, which is equal to square root of 7 plus 2 divided by 7 minus 4, or we can write it as square root of 7 plus 2 divided by 3. Exercise 1.6, question number 1, find first one 64 to the power 1 by 2. Solution. So this 64 can be written as 2 to the power 6. If you are not knowing directly, then you have to find using prime factorization method. 64, divide it with 2, then it is 32. 2 16s are, 2 8s are, then 2 4s are, 2 2s are, then 2 1s are. Likewise, we get 64 as 2 to the power 6. Again, power given is 1 by 2. We know the formula that a raised to m to the power n is equal to a raised to m into n. So same formula we will be using here. 2 raised to 6 into 1 by 2. 2 1s are, 2 3s are get cancels. Remaining is 2 to the power 3. So that is equal to 8. Now second one, 32 raised to 1 by 5. So prime factors of 32 are 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So we got 32 is equal to 2 raised to 5 whole to the power 1 by 5. So here formula a raised to m raised to n is equal to a raised to m into n. So this is equal to 2 raised to 5 into 1 by 5. 5 get cancels. Then 2 raised to 1 is 2. Third one, 125 raised to 1 by 3. This 125 factors are 5, 25 is a 5 5 is a 25, again 5 1s are 5. 125 is equal to 5 raised to 3. So this is 5 raised to 3 to the power 1 by 3. Here we are using the formula a raised to m whole raised to n is equal to a raised to m into n. So which is equal to 5 to the power 3 into 1 by 3. 3 get cancels. Then answer is 5. Question number 2. Find first one 9 to the power 3 by 2, which is equal to 9 can be written as 3 square whole to the power 3 by 2. Here we will be using the formula a raised to m to the power n is equal to a raised to m into n. So this will be equal to 3 to the power 2 into 3 by 2. 2 get cancelled. Remaining is 3 to the power 3, which is equal to 27. Now second one 32 to the power 2 by 5. This 32 can be written as 2 to the power 5 whole raised to 2 by 5, which is equal to 2 to the power 5 into 2 by 5. 5 get cancels. Remaining is 2 square, which is equal to 4. Now third one 16 to the power 3 by 2. This 16 can be written as 2 to the power 4 whole raised to 3 by 4. Now 2 to the power 4 into 3 by 4. 4 get cancels. Then 2 to the power 3, which is equal to 8. Now fourth one 125 can be written as 5 raised to 3 whole to the power minus 1 by 3. Then it is equal to 5 to the power 3 into minus 1 by 3. 3 get cancels. Remaining is 5 raised to minus 1, or it can be written as 1 by 5. Question number 3. Simplify the following. First one 2 to the power 2 by 3 into 2 to the power 1 by 5. It can be written as 2 to the power 2 by 3 plus 1 by 5. Here we have used the formula a raised to m into a raised to n is equal to a raised to m plus n. Now this is equal to 2 to the power, here we will take LCM as 15, then it becomes 10 plus 3, which is equal to 2 to the power 13 divided by 15. So which is the required answer. Now second one 1 divided by 3 cube whole to the power 7, which is equal to 1 divided by 3 to the power 3 into 7. Now it is equal to 1 divided by 3 into 7 is 21, which is equal to 3 raised to minus 21. Now third one 11 raised to half by 11 raised to 1 by 4 is equal to 11 raised to 1 by 2 minus 1 by 4, which is equal to 11 raised to LCM is 4. Here 2 minus 1, then it is equal to 11 raised to 1 by 4. So which is the required answer. Now fourth one 7 raised to half into 8 raised to half. Here we will be using the formula a raised to m into b raised to m is equal to a into b raised to m. Now it will be equal to 7 into 8 whole raised to 1 by 2. 7 into 8 is 56 to the power 1 by 2, which is the required answer. Thank you. Please like the video and subscribe my channel.